Hello all, welcome to another quick learning. Today we're going to be going over SQL and Codecademy again. So we already did part 1, part 2, part 3. Today we're going into part 4 on multiple tables. So it's going to be probably on how to join tables. If you missed part 1, I'll put a link down in the description below if you want to start there. Otherwise, let's get started. So we got an introduction. In order to efficiently store data, we often spread related information across multiple tables. For instance, imagine that we're running a magazine company where users can have different types of subscriptions to different products. Different subscriptions might have many different properties. Each customer would also have lots of associated information. We could have one table with all of the following information. It just lists a bunch of columns. However, a lot of this information will be repeated if the same customer has multiple subscriptions. That customer's name and address will be reported multiple times. That would be a denormalized table in that case. If the same subscription type is ordered by multiple customers, then the subscription price and subscription description will be repeated. This will make our table big and unmanageable. So instead, we can split our data into 3 tables. So this would be called normalization. Orders would contain just the information necessary to describe what was ordered. So you got order ID, customer ID, subscription ID, and purchase date. And then we have a subscription table, which has subscription ID, description, price per month, subscription length, and then a customer table that has customer information. In this lesson, we'll learn the SQL commands that will help us work with data that is stored in multiple tables. Alright, so examine these tables by pasting the following code into the editor. So I'm just doing Control-C, Control-V into the editor and running it. You can see the different tables here. There's an orders table, a subscription table, and a customer table. Combining tables manually. Let's return to our magazine company. Suppose we have the 3 tables described in the previous exercise shown in the browser on the right. We're going to try something new. So we got order, subscription, customers. If we just look at the orders table, we can't really tell what's happened in each order. However, if we refer to the other tables, we will get a complete picture. Let's examine the order with an order ID of 2. So here we go. It was purchased by the customer with a customer ID of 2. To find out the customer's name, we look at the customers table. And you can see that's Jane Doe at 456 Park Avenue. Doing this kind of matching is called joining 2 tables. Using the tables displayed, what is the description of the magazine ordered in order ID 1? So we got order ID 1, subscription ID 3, which means it was sports magazine. So it says type your answer on line 1 of the code. Be sure to capitalize the same as the table. Alright, so that was correct. Using the tables displayed, what is the customer name of the customer in order ID 3? So they're number 3, so we go down to the customer table, and it's Joe Schmo. Type your answer on line 2 of the code editor. See, this is line 2. Be sure to capitalize it the same as it is in the table. Run that, and that's correct. Combining tables with SQL. Combining tables manually is time-consuming. Luckily, SQL gives us an easy sequence for this. It's called a join. If we want to combine orders and customers, we would type, so we got select star, selecting all the columns. And then we have from orders table, joining in the customers table on customer ID in both tables. And this just explains what I just said. Because column names are often repeated across multiple tables, we use the syntax table name.column name to be sure that our requests for columns are unambiguous. In our example, we use this syntax in the on statement, but we also use it in the select or any other statement where we refer to column names. For example, instead of selecting all the columns using star, if we only wanted to select orders tables, order ID column, and customers tables, customer name column, we would use the following query. So here we do the table name, dot, and then the column name. If it comes from orders, it's orders dot. If it comes from customers, it's customers dot. In the the same way as on the we use the table names dot the column. Join the orders table and subscription table and select all columns. Make sure to join on the subscription ID. So we're going to do select star from orders, join subscription. Didn't spell that right. I'm just going to copy and paste so I don't get any spelling errors. On orders dot subscription ID equal to subscriptions dot subscription ID. I'll put a semicolon. That's correct. Don't remove the previous query. Add a second query after the first one that only selects rows from the join where description is equal to fashion magazine. So we're going to select this. So this is a filter condition. So we're going to put that in the where clause. So here we put where description equals fashion magazine. And run that. And that's correct. Inner joins. Let's revisit how we joined orders and customers. For every possible value of a customer ID in orders, there was a corresponding row of customers with the same customer ID. What if that wasn't true? For instance, imagine that our customers table was out of date and was missing any information on customer 11. If that customer had an order in orders, what would happen when we join the tables? When we perform a simple join, often called an inner join, our result only includes rows that match our on condition. Consider the following animation, which illustrates an inner join of two tables on table1.c2 equals table2.c2. So you'll see here they match, so it'll use that row. Here they match, it'll use that row. And it throws away the information, any rows where they can't find a match in the other table. First and last rows have matching values of C2. The middle rows do not match. The final result has all values from the first and last rows. It does not include the non-matching middle row. Suppose we are working for the Codecademy Times, a newspaper with two types of subscriptions. Print newspaper, online articles. Some users subscribe to just the newspaper, some subscribe to just the online edition, and some subscribe to both. There's a newspaper table that contains information about the newspaper subscribers. Count the number of subscribers who get a print edition using count. So we're going to do select, count, star will count all the rows. From newspaper is the table, and end it with a semicolon. And we're waiting. It's a little slow, and it was correct. Do not remove your previous query. There's also an online table that contains information about the online subscribers. Count the number of subscribers who get an online newspaper using count. So this has the same structure. It's just we're going to change this to online instead of newspaper. There we go. Do not remove the previous query. Join newspaper table and online table on their ID columns, the unique ID of the subscriber. How many rows are in this table? Okay. So let's start with this one actually. And then we're going to inner join. Well, you can put inner join or join, it doesn't matter. Online, we're going to do that on newspaper dot ID equals online dot ID, because this ID column is coming from newspaper and this ID column is coming from online. And that's got 50 rows. Left joins. What if we want to combine two tables and keep some of the unmatched rows? SQL lets us do this through a command called left join. A left join will keep all rows from the first table regardless of whether there is a matching row in the second table, considering the following animation. So again, we have first and third rows are matching. The middle row is not, but it keeps all the information from the first table and throws away any non-matching rows from the second table. So that represents a table operation produced by the following command. So again, we're selecting all of the columns with a star from table 1, and then we're left joining to table 2 on the C2 column from table 1 and from table 2. So we will have all the rows from table 2, whether they join one from the other table or not. Or sorry, all the rows from table 1, whether you can find a match in table 2 or not. And we only have the rows from table 2 where there is a match between the two on the C2 column. Let's return to our newspaper and online subscribers. Suppose we want to know how many users subscribe to the print newspaper but not the online. Start by performing a left join of newspaper table and online table on their ID columns and selecting all columns. Okay, so we're going to select star from newspaper. And we're going to do left join online on newspaper. God, I can't spell today. Newspaper.id equals online.id. Selecting all columns, okay. I think that's correct. Okay. Don't remove your previous query. In order to find which users do not subscribe to the online edition, we need to add a where clause. So we're going to add a second query after your first one that adds the following where clause and the condition. So we're just going to add this, and we're going to add the where clause here, where online ID is null. So wherever there's not a match, the online ID is going to be null. So this is only giving us the ones where they only subscribe to the newspaper. That's correct, and that's end of that section. Primary key versus foreign key. Let's return to our example of the magazine subscriptions. Recall that we had 3 tables: orders, subscriptions, and customers. Each of these tables has a column that uniquely identifies each row of that table. We got order ID for orders, subscription ID for subscriptions, and customer ID for customers. These special columns are called primary keys. Primary keys have a few requirements. None of the values can be null. Each value must be unique. You can't have 2 customers with the same customer ID in the customers table. A table cannot have more than 1 primary key column. Let's re-examine the orders table. Note that customer ID is the primary key for customers, and subscription ID the primary key for subscriptions. Both appear in this. When the primary key for one table appears in a different table, it's called a foreign key. So in this orders table, the order ID is the primary key, and customer ID and subscription ID are foreign keys, and the customer ID would be the primary key in the customers table, and the subscription ID would be the primary key in the subscriptions table. So why is it important? The most common types of joins will be joining a foreign key from one table with the primary key from another table. For instance, when we join orders and customers, we will join on customer ID, which is a foreign key in orders, and the primary key in customers. Suppose Columbia University has 2 tables in their database. The classes table contains information on the classes that the school offers. Its primary key is ID. The students table contains information on all students in the school. Its primary key is ID. It contains the foreign key class ID, which corresponds to the primary key of classes. So usually the primary key in a table will be called ID, and foreign keys will usually have some identifier before that, like class ID or something that tells you which table it probably comes from. So perform an inner join of classes and students using the primary key and foreign keys described above and select all columns. All right, so we're going to select star from classes, and they're doing an inner join, so we're just do join students table on doing classes dot ID is the primary key in the classes table, and then that matches up with students dot class ID as the foreign key in the students table. That's correct. Cross join. So far we've focused on matching rows that have some information in common. Sometimes we want to combine all rows of one table with all rows of another table. For instance, if we had a table of shirts and a table of pants, we might want to know all the possible combinations to create different outfits. Our code might look like this. So we're doing cross join across the shirts and the pants, and we're just selecting the shirt color and the pants color. Notice the cross joins don't require an on statement. You're not really joining on any columns. We have 3 different shirts, white, gray, and olive, and 2 different pants, light denim and black. The results might look like this. So you can see, so we got 3 times 2, so there's going to be 6 columns, so 6 combinations, yes, and it's every different combination you could possibly have. So the white goes with the 2 different types of pants, gray goes with the 2 different types of pants, and olive goes with the 2 different types of pants. This coding example is fun, but it's not very practically useful. The more common usage of cross-join is when we need to compare each row of a table to a list of values. Let's return to our newspaper subscriptions. This table contains 2 columns that we haven't discussed yet. Start month, the first month where the customer subscribed to the print newspaper, 2 for February. End month, the month where the customer subscribed to the print newspaper, the final month. Suppose we wanted to know how many users were subscribed during each month of the year. For each month 1, 2, 3, we would need to know if a user was subscribed. Follow the steps below to see how I can use a cross join to solve this problem. Okay, eventually we'll use a cross join to help, but first let's try a simpler problem. We'll start by counting the number of customers who subscribed to the newspaper during March. So use count star, so we're going to do select count star from newspaper is the table, and they've given us the where conditions here. We're restricting it to a start month of less than or equal to 3 and a end month of greater than or equal to 3. All right, and then semicolon to finish it off. I'll run that. That's correct. Moving on, don't remove the previous query. The previous query lets us investigate 1 month at a time. In order to check across all months, we're going to need to use a cross join. Our database contains another table called months, which contains the numbers between 1 and 12. Select all columns from the cross join of newspaper and months. All right. So we're going to do select star from newspaper, and then we're going to cross join the months table. I think that's all it wants for now. We'll see. Thinking. It is correct, yes. All right, don't remove your previous query. Create a third query where you add a where statement to your cross join to restrict to 2 conditions. All right, so we're just going to copy and paste this, and then we're going to put in the where condition here, where start month is less than or equal to month from the month table, and end month is greater than or equal to month. This will select all months where a user was subscribed. It's thinking that's correct. Don't remove your previous query, create a final query where you aggregate over each month to count the number of subscribers. Fill in the blanks in the following query. It's basically the same thing as this, except we're going to do, in the select statement, we're going to do month and count star, and then we're going to group by the month. So this is going to go for each month, and it's going to count the number of times we have a subscription there. All right, that's correct. I'm going to go next. Union. Sometimes we just want to stack one data set on top of another. Well, the union operator allows us to do that. Suppose we have two tables and they have the same columns. So we've got Pokemon, and then we've got type. Table 2, we've got more Pokemon and another type. If we combine these two with union, so it's just select star table 1, so it's just appending the second table to the first table. Make sure your rows match up. The result will be this. SQL has strict rules for appending data. Table must have the same number of columns. Columns must have the same data types in the same order as the first table. Let's return to our newspaper and online subscriptions. We'd like to create one big table with both sets of data. Use the union to stack the newspaper table on top of the online table. So we're going to select star from newspaper, and then we're going to union select star from online, end it with a semicolon, and that's correct. With. Oftentimes we want to combine two tables, but one of the tables is the result of another calculation. Let's return to our magazine order example. Our marketing department might want to know a bit more about our customers. For instance, they might want to know how many magazines each subscriber subscribes to. We can easily calculate this using our orders table. So here we've got select customer ID. We're counting the number of subscription IDs from orders and grouping by customer. This query is good, but a customer ID isn't terribly useful for our marketing department. They probably want to know the customer's name. We want to be able to join the results of this query with our customers table, which will tell us the name of each customer. We can do this by using a with clause. So here you've got the with. You give it a name, and then you go as, and then your query. And then in this query, you can see it does select star from previous results, which is the name of this. So it's using this table that we create, and then joining it to customers and using the on condition. Okay. Essentially, we're putting a whole first query inside the parentheses and giving it a name. After that, we can use this name as if it's a table and write a new query using the first query. Place the whole query below into a with statement inside parentheses and give it the name previous query. So here we go, previous query, and then we're going to do as, and we're going to copy and paste this. So I'm going to tab this. All right. Join the temporary table previous query with customers. We're going to do select and select the following columns. Okay. So we want customer name. What the heck? Control Z. Somehow I got two cursors there. Interesting. And then what else do we want? We want the previous query subscriptions from the previous query. And we're joining it with customers on previous query dot customer ID and equals, customers dot customer ID. All right. Let's run that. And that's correct. All right, now we're going to do a review. In this lesson, we learned about relationships between tables and relational databases, how to query information from multiple tables using SQL. Let's summarize what we learned so far. Join will combine rows from different tables if the join condition is true. Left join will return every row in the left table, and if the join condition is not met, null values are used to fill in the columns from the right table. So there's also a right join that does the same thing, except it'll take every row from the right table and put nulls in the left table. Primary key is a column that serves a unique identifier for the rows in the table. Foreign key is a column that contains the primary key to another table. Cross join lets us combine all rows of one table with all rows of another table. Union stacks one data set on top of another. With allows us to define one or more temporary tables that can be used in the final query. All right, that's it for this lesson. Hope you guys were able to follow along and learn something. Thank you very much.